Consecutive integer problems, the invasion of consecutive integers. So let's go through some terminology to start with. Consecutive integers are integers that differ by 1, like 1, 2, 3, 4. Consecutive even integers would be like counting by even numbers, like 50, 52, 54, 2, 4, 6, 8. Consecutive odd integers would be like 17, 19, 21, 3, 5, 7. Be like counting by odd integers. So how could we describe the next consecutive integer if your first number is the variable n? So if I start with n, how can I describe the next number that would come after n, the next consecutive number? Well, no matter what number I start with, to get to the next consecutive number, all I would need to do is add 1. And the following consecutive number, I could take n and I could add 2. So no matter what number I started with, if I started with 5, I'd have 5. 5 plus 1 is 6. 5 plus 2 is 7. I'd have 5, 6, 7. Or if I started with 100, then I'd have 100. 100 plus 1 would be 101. 100 plus 2 would be 102. So the relationship between a number and its next consecutive number would be n and n plus 1. Now, let's look at the number line. We've seen the number line for a long time, but let's talk about it as it's referring to consecutive integers. So if I look at the number line, how far apart are even numbers on the number line? Well, even numbers are 2 numbers apart on the number line. And how far apart are the odd numbers on the number line? Well, the odd numbers are also 2 apart on the number line. Well, shouldn't odd numbers be an odd number apart? Well, no, that's not really how the number line works. If I start with an even number, if I start with 2 and add 2 to it, I get to the next even number. Or if I start with 1 and I add 2 to it, I get to the next odd number. So even numbers and odd numbers actually have the same relationship on the number line. They're both 2 apart on the number line. So how can we describe the next consecutive even integer if your first number is the variable n? Well, if we start with n, the next consecutive even number would be 2 greater, would be n plus 2. And if we wanted to do a third number, n plus 4, and a fourth number, n plus 6, then n plus 8, then we could just keep adding 2 to describe the next even integer. And if we start with an even number like 10, we'd do 10, 10 plus 2 would be 12, 10 plus 4 would be 14. How can we describe the next odd integer if your first number is n? Well, back to what we were talking about on the number line. If I start with an odd integer, to get to the next odd integer, I'm actually adding 2 again. I'm not adding 1 or 3, even though it says odd. The next odd integer on the number line would be 2 greater. So our setup for evens and our setup for odds are the same because they both have the same relationship with the number line. And our third number would just be n plus 4. So the relationship between even and odd numbers is the same as far as when you start with an even number and add 2, you get to the next even number. If you start with an odd number and you add 2, you would get to the next odd consecutive integer. So let's look at a typical problem. We have find 3 consecutive integers whose sum is 75. So first of all, we need to identify the problem. Are we talking about consecutive integers, consecutive odd, consecutive even? This just says consecutive. So consecutive, I would know my first number would be like n, the next consecutive number, n plus 1, and the third number, n plus 2. So that's the relationship between any 3 consecutive integers. Then I need to write an equation based on this. We have find 3 consecutive integers whose sum is 75. That means they add up to 75. I can write my equation n plus 1 plus n plus 2 equals 75. Combine like terms. Subtract 3 from each side. Divide by 3. And my first number is 24. So if my first number is 24, then I can find the next number as 24 plus 1 is 25. and n plus 2 is 26, so my three numbers are 24, 25, 26. All right, new problem. We have the sum of three consecutive odd integers is negative 45. All right, they're talking about consecutive odd. So if our first number is n, how do I get to the next odd number? N plus 2. And our third odd number, n plus 4. So we have n plus 2, n plus 4 as a relationship between those. Then we need to write our equation. And from our problem, we have the sum of three consecutive odds. So that means we add n plus 2, n plus 4 together to get negative 45. Then we could solve for n. Combine like terms. Subtract 6 from each side. Divide by 3. And I get my first number is negative 17. And if I start with negative 17 and then I add 2 to it, it actually gets larger. We go to negative 15. And our third number, negative 13. So I know there's people out there saying, well, you're doing it really the hard way. Well, we're practicing writing and solving equations, and you're not going to be able to check and guess problems like this. We have find 5 consecutive even integers if the sum of the first and fifth is 2 less than 3 times the fourth. Wow, that sounds really difficult, but if we break it down and follow our same pattern, we can work this out pretty easily. So we have 5 consecutive even integers. So we've determined that it's not consecutive, it's just consecutive even. So if the first one is, let's say, we'll use another variable, let's say we have x, then the next number x plus 2, then x plus 4, then x plus 6, and x plus 8. Now, to write the equation, we have the sum of the first and fifth. Sum of the first and fifth. So the first is x, the fifth is x plus 8. So to find the sum of the first and fifth, I have x plus 8, and then I have the word is would be equals, 2 less than 3 times the fourth. 2 less than, so I'm going to subtract 2 from 3 times the fourth. Well, the fourth is x plus 6. 3 times the fourth is 3 times x plus 6, and 2 less than that is subtract 2. That's where my equation comes from. So notice how in this word problem, it didn't actually use the second and third because it didn't give us a relationship to write the equation. So even though we have the relationship of those numbers to start with, we did not need that part to write the equation. So now we need to solve our equation. We can combine like terms. We can distribute the 3. 3 times x is 3x. 3 times 6 is 18. Bring everything else down. 18 minus 2 is 16. Then we can get all the x's to one side. I have 2x on the left side, 3x on the right. I can subtract 2x from both sides and subtract 16. So my first number is negative 8. So I have negative 8. Then if I add 2, negative 6. Add 2 again. And I get negative 8, negative 6, negative 4, negative 2, and 0. All right, I think you guys are ready to try something on your own. You guys pause the video here. See if you could solve this and come back and see how you did. All right, we're trying to find 3 consecutive odd integers that the sum of the smallest and 4 times the largest is 61. So consecutive odds. So if my first number is, we'll use n again, we'll do n, and the next odd number, n plus 2. And we have 3 numbers, so I need n plus 4 for the third number. Then if we're looking at which is the smallest and which is the largest, if I take any number, add 2 and add 4, this number is going to be smallest. And any number I start with and add 4 would make this number the largest. So we come to write our equation, 3 consecutive odd integers of the sum of the smallest, so smallest being n, and 4 times the largest. So 4 times n plus 4. So sum means we're going to add together n, and 4 times the largest, 4 times n plus 4, is 61, means equals 61. Then we could distribute the 4, 4n plus 16, combine like terms, subtract 16 from each side, divide by 5, and n is 9. So if my smallest number is 9 or n is 9, 9 plus 2 is 11, and 9 plus 4 is 13. My numbers are 9, 11, and 13. And I hope that gets you guys going on consecutive integer problems For Mr. Slope Guy, OUT spells out.